Okay, thank you. Okay, so this is about a committee who's going to take a vote. The committee members are going to care about the quality of their decision. They're each going to have some information, and they want to aggregate that information. So they want to get a good outcome. And in some settings, committee members don't just care about getting the right outcome, but they also care about how their actions, how their votes are perceived by other people. So just as an example, elected officials, of course, we hope, care about voting for the right thing, but they also care about what their constituents want, right? They don't want to be seen as publicly voting against their constituents' desires. Corporate board members, they care about how their votes, how their actions on a board are perceived by shareholders, and faculty members don't necessarily want candidates to know how they voted when they were up for hiring or tenure or something like that. Okay, now sometimes not only do these committee members care about how their votes are perceived, but they don't want to be seen as voting in any specific way. Okay, they want to maintain, they have a preference for keeping their votes ambiguous. Okay, so for example, the elected official might have heterogeneous constituents, and it doesn't matter how he's seen as voting, he might alienate some of his constituents. So he doesn't want to be seen as voting in a particular way. Same for the corporate board members. They don't want to anger any of the shareholders, even though these shareholders might have different opinions. And the faculty member doesn't want to be seen as voting against either one of the candidates if he's deciding for one against the other. So here's a conjecture that you might have in this sort of setting where the voters care about how their votes are perceived. So you might think, well, I want to maintain ambiguity of my vote, so I should not reveal a lot of information about how people voted. So in particular, we might want to have something like anonymous voting, right? We're all going to vote, and the only thing that gets publicized is just an anonymous tally of the votes. Okay, and this is probably better than open voting, where everybody gets to see how everybody else voted. Okay, so that's pretty reasonable. You might actually be able to do better, maybe. So even if you reveal a tally of the votes, that still reveals some information. So maybe even better than that would be secret voting. So let's not reveal anything except the outcome of the vote. Okay? Okay, so these are 3 different ways of revealing information. And the conjecture is you might want to reveal as little as possible. So this paper is about this conjecture being false, and in fact, restricting the amount of information for voters who care about how their votes are perceived could be harmful. Okay, so I'll be a little bit more specific about the setting that I'm looking at. So there's going to be a common value setting. So it's what Ansan called objective opinion. So there's some ground truth. The ground truth here is one of 2 states of the world. And each of the committee members is going to get some signal about the true state of the world. Okay, and what I'm going to do is I'm going to compare, they're going to vote, and I'm going to compare 3 information disclosure regimes. So open voting, where everybody's vote is disclosed, anonymous voting, where it's just an anonymous tally, and secret voting, where just the outcome is revealed. And I'm going to compare it along 2 dimensions. One is the probability that they get the outcome right? So there's an objective truth here, so it's a probability that they make the right choice. And the other dimension is the welfare of the voters. How happy are they with the outcome plus whatever information was disclosed? Right? In standard settings where they don't have a preference for strategic ambiguity, these are the same, but here they're not, because the amount of information that's disclosed affects their welfare, but not the likelihood of the right outcome being chosen. Okay, so the main result, as I said, is that the amount of information that you disclose has a non-monotonic effect on both of these dimensions, both on the probability of correctness and on the welfare. So let's look at the probability of correctness. So in the setting that I study, the first best probability of correctness is going to obtain at the extremes. So when everything is revealed, so open voting, or when nothing except for the outcome is revealed, that's secret voting. Okay, you're going to get the first best probability of correctness. But in this middle case of anonymous voting, where some but not all of the information is revealed, it's going to be lower. Okay, you're going to do worse along that dimension. In terms of the welfare, for open voting, the welfare is always going to be the worst, because these guys don't want to be seen as voting in any particular way. But what I'm going to show is that sometimes anonymous voting is better than secret voting. Sometimes you do want to reveal a little bit of information, and this is better for the committee members. Okay, so this middle case is now better than the 2 extremes. So it's a non-monotonicity in the other direction. Okay, so here's some intuition for how to get this. So first I'll tell you about sincere voting, which is basically where the voters are not strategic. They get some information, they just vote according to their information. Okay, so in this case, the probability of correctness is what it is, regardless of what information you reveal in addition to the outcome. And in terms of welfare, it's what you'd expect. The less information you reveal, the better it is for the committee members. Okay, because they don't want to reveal information. Okay, now, what if voters vote strategically? And not just according to the information that they get, they also think about how others are voting. So the setting that I look at, voting sincerely is going to be an equilibrium in these two extreme cases, in open and in secret voting, but not in anonymous voting. Okay, they're going to want to deviate from that. They're going to be doing something else. And so why is it not an equilibrium here? So let's think about the two things that happen if you deviate from how you're going to vote. So if I vote against my signal, if I vote with my signal, that increases the probability of getting the more likely correct outcome. If I vote against it, then I go towards the other guy, the one that's less likely correct. Okay, but sometimes, if I deviate from my signal, that doesn't change the outcome, right? There are other people voting as well. And in that case, I might be better off because deviating is actually going to increase the noise in the tally of votes under anonymous voting, which is beneficial if these guys care about maintaining ambiguity about their votes. Okay, so one way to think about this, in the extreme case, suppose everybody voted the same way, we're all voting against the candidate, right? Then that basically reveals everybody's information, even though it's an anonymous tally. Then we would gain by having one player deviate and vote for, and because it's anonymous, nobody knows who voted for, so there's more uncertainty. So we all feel more comfortable having some chance of being the person who voted in favor of the candidate. Okay, so there's a trade-off here between voting for the more likely correct outcome and voting against it, but trying to get more uncertainty. Okay, there's a trade-off here, and I have some conditions under which this trade-off goes towards the latter. You want that uncertainty, and then sincerity is not in equilibrium.
But how do the voters evaluate this uncertainty? If there is one deviating, one non-standard vote, as opposed to two, what difference does it make?
No, so here I'm just trying to argue why sincere voting is not an equilibrium. Okay, so it is going to make a difference for them. So it'll be clear in the simple model that I'll show you, because it'll be two voters, and then there's a big difference between uncertainty and full certainty. But more generally, it could be that you want to be as close as possible to being 50-50 or something like that. Okay, that's the kind of thing that.
The voters.
I'm sorry?
That's to express.
From the outside observer's perspective.
Something in the voters' welfare.
Yes. Yes. That's right. Okay, so I just argued that sincere voting is not an equilibrium. In an equilibrium, the voters are going to mix, so they're injecting some randomness into their voting. Sometimes they're voting against their signal. And of course, this lowers the probability, or lowers information aggregation, lowers the probability of getting the right outcome. And sometimes this randomization increases welfare. And in particular, there are some cases where this welfare increase suffices to surpass the better welfare under secret voting with sincere voting. Okay, so more uncertainty but less accuracy is sometimes better than secret voting with sincerity. Okay, and then what we get is that the equilibrium in anonymous voting has lower probability of correctness than the extremes, but sometimes higher welfare than the equilibrium in the extremes. Okay, so it's related. The framework is the basic common value voting framework. We look at a setting with enough symmetry so that the strategic voting effects that happen here don't happen. In the setting that I look at, you could have both, and then they either reinforce one another, or go in opposite directions. Okay, but I want to focus on the effect caused by the preference for strategic ambiguity. Okay, and these preferences are also related to other strands of the literature, which I don't have time to talk about. Okay, so for this talk, we're going to focus on committees of size 2. A good part of the paper also focuses on that. And then I have other results for large committees. Basically, a lot of the qualitative results do go through for larger committees, but it's harder to calculate equilibria, which I need to do for some of these theorems. Okay, so I already told you 2 states of the world. Outcomes are also A or B. So A is the right outcome in A, B is the right outcome in state B. Each one of the voters gets a conditionally independent signal about the state of the world, and then they vote, either for A or for B. And the outcome is determined by a procedure, which is both the voting rule, what's the outcome, and the disclosure rule, what information is disclosed. Okay, so we're going to focus on a particular voting rule, which is basically unanimity. So think of B as the status quo, and if both voters vote for A, then we choose outcome A, otherwise we stick with the status quo B. Okay, and we focus on these three information disclosure rules. And the utilities of the two players are determined both by the outcome, so they get utility 1 for getting the right outcome, and 0 otherwise, and then there's another element which has to do with the inference made about how they voted. So to think about this, imagine there's a third player, the observer. Okay, he has no information, he just observes what happens, and basically he tries to infer the voters' votes from what he sees. So in open voting, he can completely infer each player's vote. In anonymous voting, sometimes he can. So if 2 voted for the same thing, then he knows how everybody voted. But if the tally is 1-to-1, then he hasn't learned anything beyond 50-50 chance of each player voting in each direction. Okay, and in secret voting, if the outcome is A, then he knows both voted for A. If the outcome is B, then he has to infer what the probability is that each voted. And this depends both on the accuracy of the signal and on the strategy profile that they employ. Okay, so here's the utility of a player. So each player is going to have a cost function. Okay, so given some outcome, given some state and an outcome, the utility is going to be 1 if it's the right outcome, minus the cost of the inference. So think of the inference as the probability that the observer assigns to this person having voted for the status quo, for B. Okay, so I want to capture a preference for strategic ambiguity, so I'm going to do that through this cost function. So the simplest setting to think about is the cost for having complete ambiguity, 50-50 voting A or B, is 0, and everything else is non-negative. And I'm going to think of the cost function as being convex. Okay, so if the inference is close to a half, then that's almost as good as a half, but as we get closer to the extremes, then there's some significant cost involved. Okay, there's some simplifying assumptions, the players are symmetric, and the second one, that if the observer knows you voted A or knows you voted B, it's the same cost. We'll call that C, and C will just be a parameter for how costly is it to have your vote revealed. Okay, so here are some propositions about equilibria. So in open voting, sincere voting is the unique equilibrium. In secret voting, it's the unique equilibrium unless the cost is very high the cost to having your vote revealed. I don't have time to tell you why that's the case. Okay, but here's the main thing, which is that in anonymous voting, the unique equilibrium is mixed. In particular, when they get a signal A, they vote A. If they get a signal B, sometimes they'll still vote for A. Okay, so how about welfare? So under sincere voting, welfare is ranked how you'd think. So the utility under open voting is less than the utility under anonymous voting, which is less than the utility under secret voting. Okay, it's parameterized by the probability P of the signal's accuracy. With strategic voting, this ordering is no longer necessarily the case. So here are some settings where the monotonicity breaks down. So for example, when the privacy costs are higher than some threshold, or when signals are more accurate than some threshold, or when C is not too convex, or this is a more general result for an asymptotic result for a large number of players. So if the number of players is larger than some threshold, this is also the case. Okay, in these cases, basically the last two are switched. Okay, so anonymous voting leads to higher welfare for the voters than secret voting. Okay, and the intuition is that just in these cases, the cost to getting the wrong outcome is smaller than the benefit to getting more ambiguity. Okay, so just a quick recap. So we looked at a common value setting where voters care not just about the outcome, but also about how their votes are perceived, and in particular, they want to maintain some ambiguity about how they voted. We compared open voting, where all the votes are disclosed, anonymous voting, where just an anonymous tally is disclosed, and secret voting, where nothing except the outcome is disclosed. And the main results are that the amount of information that you disclose has a non-monotonic effect on both the accuracy of the outcome and the welfare of the voters. Okay. Thank you.